Okay, so why we believe that graphene is really making something, and it can be sort of increase this European competitiveness and so on, and why it's a good source for innovations as well. So first of all, graphene itself is really a unique material. So it has a huge set of unique properties, but it has, even more importantly, a unique set of these unique properties. So there's just listed a few that it has unique thermal properties, chemical properties, mechanical, electrical, and optical, and so on. And all this means that there's a huge set of different applications and different industries which are interested in this graphene itself. So there's this both technological push and technological pull already existing. But even then, so there's actually quite many different technologies or materials which have been at least promising to make a big impact, but which hasn't necessarily been successful. So why we believe that graphene is different? So first of all, graphene is really a radical technology as such that there's not just an incremental performance increase, that there's really a significantly higher performance in many different applications. But secondly, I already mentioned that there's a lot of different applications, and it means that it's a generic technology. And this wide variation of applications are, again, it's creating this pull and this need for developing this graphene technology itself. Okay, it's a platform technology. I guess silicon is nowadays a pretty good platform technology. So you can have MEMS, NEMS, different kind of integrated circuits and so on. And many different things are made by using silicon, out of silicon. Graphene can be a similar platform, but wider than silicon even. Because there is, again, a lot of different applications. Last in this list is that this graphene itself is also a disruptive technology also from business perspective, because it can really offer completely new value propositions. For example, in enabling better printed electronic circuit and changing and disrupting this present manufacturing paradigm. The last thing, what is not even mentioned here, is that I guess, in my opinion, there's actually pretty easy industrial adaptation when we are talking about graphene technology, simply because it's a thin film technology. Many other technologies, let's say carbon nanotubes or whatever, they are not sort of fully compatible with existing systems. But graphene is really a thin film, and it's relatively easily to be implemented on that sense. Okay, couple of words that quite often this when we are talking about graphene, these short-term applications are also mentioned, which are perhaps already almost here in a marketplace and commercial products. I guess I actually like this famous Cramer's lemma of new technology very, very much, because it's really strongly related to graphene. So this lemma is that the principal application of any sufficiently new and innovative technology always have been and will continue to be application created by the technology itself. So in this case, this principal application of graphene will be based on graphene itself, most likely. So okay, why we still sort of we are creating, for example, Nokia, some flexible things which are not necessarily going to be a principal, this technology in the end, or this application. But these short-term applications will really pave or create this way towards these fundamental applications, because they will create this need to develop that graphene technology itself, or any technology itself. But just to note that, of course, however, even these short-term low-hanging fruits or these short-term applications must bring something new in price-wise or increase in performance or new attributes, such as flexibility. Okay, having said all that, so this mission of graphene flagship is really how we wrote that we will take this graphene and related layered materials from the state of the raw potential to point where they can revolutionize multiple industries, a faster, thinner, stronger, flexible, and broadband revolution. And okay, our program will put Europe firmly at the heart of the process with a manifold return of investment in terms of technological innovations and economic exploitation. So there's really this that our aim is really to make this commercialization to happen and really make this economical impact also stronger. Okay, just a really brief explanation of how this process has been going. So we are pretty much here now. I guess these negotiations are. I guess they are. Yeah. This whole process has been longish and time and energy consuming, perhaps as well. And I'm not going to details, but I can say that when this pilot program, this coordination action, was accepted, we had a kick-off meeting for that program in the very same building where we are now, roughly 2 years ago. And since then, we have been sort of really driving this graphene flagship in full speed. Originally, I guess there was roughly nine partners, and I have been personally involved from the very beginning. Okay, last October, this proposal was submitted, and January it was selected, and the aim is that this project will start in the 1st of October. Okay, this acceptance quite clearly produced a huge amount of publicity or media interest. There was really Financial Times and a lot of things that here is calculated that at least 1,300 media clippings with approximately 1.8 billion possible readers and so on. Perhaps just a short anecdote that related to this, that it has produced so much interest that the CEO of Nokia was calling me personally, and I was really surprised that this, actually my name was sort of in a wrong contest, I guess. Okay, then I'm moving more to these actual competitiveness and innovation aspects. I said that the mission for this graphene flagship is really take this raw potential and make some commercial applications to happen, or take this graphene really to marketplace. So how do we succeed in our vision or mission? First of all, by focusing on different kind of value chains. And I guess, as was already said, that there's a kind of intellectual value chain existing as well, that really from fundamental research to applied research to industrial research. So from exploratory phase to sort of solve phase and to deliver phase. So we are focusing on all these different aspects to cover this whole channel. A second important part is a kind of industrial value chain, especially in ICT industry. But I guess it can be roughly divided into 3 different categories. For the first part, focusing on materials, and then there's component manufacturers and suppliers, and then there's system integrators. For instance, Nokia is nowadays in this system integrator level, at least my opinion. I don't know if that is official statement. Of course, quite standard other things what we are aiming to do, and I'm going to explain later what this means in a graphene flagship. But of course, we will try to maximize these different kind of impacts. But we are also putting an emphasis also in SME participation, small and medium enterprise participation. And as a last part, I guess that was perhaps already sort of a natural part of this flagship activity itself. But one important thing is that we really have a coherent, clear scientific and technological roadmap, which was created and what we are following. Okay, maximizing the scientific and technological impact. So how we plan to do that, and what we were proposing when we brought our proposal. So first of all, we will really focus on critical mass. So in order to have something big to happen, usually you will need a sort of a bigger thing, in a coherent bigger thing to combine different things together. And I guess this flagship will offer that. So it will definitely have that aspect. We will have a knowledge focus, meaning that this research, education, and also this innovation part, which are sort of clearly combined. We will also have an application emphasis that I guess there's this good set of applications, and we will have that focus in mind. Of course, because flagship is, or these flagships, both of these are large projects or large initiatives, there will clearly be a kind of halo effect around these projects as well. And of course, we need some instruments, and so we need to ensure that we can benefit and utilize also this halo around these topics within flagship and also, of course, outside of these projects. A last part is that we have, of course, this clear target in mind and this roadmap. But in order to have also some kind of feedback mechanisms and steer these actions, we need a certain amount of flexibility. And again, there's some built-in tools and instruments to take care of this flexibility as well. There's this open call start and so on. Okay. When we were sort of formulating this graphene flagship proposal, we did some investigations and sort of we had some discussions how to sort of or what are these challenges and how to tackle with these challenges to get to strengthen this SME participation in these projects, or in general in large publicly funded projects. So one of these kind of identified thing was that SMEs are usually not keen on waiting call or prepare these proposals. That if they have an idea, they would like to sort of get that implemented as soon as possible, and it's, these timelines can perhaps be too long. Secondly, usually, especially in large projects, this administration can be really heavy, and SMEs don't usually have sort of so strong support functions as universities or large corporations. Universities are usually having its officers for taking care of this European Union activities, but SMEs don't. So this was really considered to be a problem, the liquidity problem. But I guess sometimes if these SMEs, that if they are in the really starting phase, they don't necessarily even just have enough cash to sort of start or run to these projects before they will get this funding. In our proposal, we wrote, I'm emphasizing that in our proposal that we wrote a couple of proposed ideas in general. So one idea was that what about if large companies, for instance Nokia in our case, are sort of applied to purchase items from SMEs if these large companies are funded, for instance for running this project. I guess this is used in US, according to my understanding. It has been quite successful as well. Small implementation grants. I mean, implementation grants if some SMEs are willing to sort of implement ideas created within that project. That's all. Projects should organize seed funds to sort of really, again, start companies and so on. And in this case, not necessarily by using that project funding itself, but for instance, by creating matchmaking, really to combine researchers and funding agencies. Okay, sales and marketing grants. SME help desk. First of all, of course, there's this project administration office, but another kind of help desk is possible as well. Kind of a dragon's den to help these SMEs to sort of get started and sort of evaluate these ideas. And I guess the last part, that these IPR rules must be SME friendly. That these SMEs must be capable, and also large corporations, capable to utilize these results, really. We have some ideas and some thoughts and some proposals, and so on. I'm just thinking that if I don't have any other slides related to this intellectual property management, I will come back to this topic. Let's see. Okay. Challenges in making an economical impact. I already mentioned this supply or value chain aspect, that we will focus on that. And it's clear that actually, especially in Europe, we have a challenge in ICT supply chains. Because if you are thinking European ICT companies as compared to, let's say, companies in Asia, this vertical integration is really thin in Europe. Again, I'm saying that, for instance, Nokia is really a system integrator, ST Microelectronics is providing components, and so on. So there's a clear challenge that, first of all, how to get ideas through, and how to really sort of, how to say this. In Europe, who is the first to invest in new technology? Because you don't necessarily have a customer yet, but this customer can't invest in this new technology because they don't necessarily have a supplier for that technology. Whereas in some other countries in Asia, some companies are having this full vertical integration, starting from materials to full systems, so this kind of decisions are easier. Secondly, for corporate research perspective, that is also a challenge. But I guess, again, I'm working for the Nokia Research Center, and I guess it might be challenging to get ideas through, especially because of this kind of thing. That if we don't do things in-house, and we will automatically always need some other parties and things. So we identify that this is, of course, a clear sort of opportunity for large projects with a certain amount of critical mass, such as graphene flagship. Okay, a second thing what was written in this proposal, that I guess tech transfer is difficult, and it's traditionally slightly difficult, at least in Europe. One reason is, again, this supply chain kind of thing, and this value chain thing. But secondly, in innovation, there's, of course, first this invention part, but then there's also this making some commercial things out of that invention. So you will need some funding for the technology as well. And it was identified that traditionally Europe has not been strong in these non-R&D aspects on this innovation process. Of course, nowadays it might be even challenging to find funding because just because of this present economical climate. But this funding might be challenging, but also that I guess it might be easier to get fund for, let's say, software-related things because of these shorter timescales, whereas in hardware, these timescales are long-ish, and that will also give some other challenges. But again, this flagship can provide a seamless route to market, and this strong industrial engagement will also hopefully make this tech transfer easier and more successful. Okay, here it is. This innovation and IPR management is quite often weak in publicly funded projects. These individual participants are filing patents individually. Of course, usually projects are having consortium agreement, which is sort of saying these different framework programs are also given some rules. But this kind of coherent IPR management is missing. And there's one important aspect here, that it's always so that the patent portfolio is stronger than a set of individual patents. So at least even a patent or IPR database will make these things more clear. So we need, again, an opportunity that some new models for handling this IPR, but at least some kind of database, and which will then be clearly and quite automatically more appealing for investors and for corporations and so on, really to make this innovations to happen. Okay, one aspect also in graphene flagship, which was also mentioned before in this flagship concepts in general, but I guess the idea is that this industrial engagement will get stronger during this project. So we will start by having a strong emphasis in materials and this basic application development, and by having strong academic participation. But then step by step we will move more towards, let's say, component level research and different sort of application research, and at the same time all the time increasing this industrial sort of engagement as well. And in the end, we will put a lot of focus on sort of real commercial applications and this system-level integration with largest possible amount of industrial engagement. Quite dark slide. Okay, just a few words about this present flagship consortium. So we are having at the moment 75 or 78 partners, 75 around that. So 128 different groups from 17 countries. These different partners are really coming from academic side, from academia. We have different research institutes, and we have pretty strong industrial engagement already. Okay, then this value chain aspect is mentioned again. This governance structure is going to be following. That, of course, this basic entity is this graphene consortium itself. There's some elements, but this actual work is divided in 11 different research work packages and one innovation-focused work package. So we will have a work package focusing on innovation and really making some proposed things to happen. And everything is sort of coordinated by this executive board comprising this director, work package leaders, and some other parts as well. Okay, and we have also strategic advisory council, which consists of so key figures on this area. Then another example of this idea that there's this application focus, but we also have this fundamental research background in everything what we are doing. So these different work packages could be divided into 3 different maturity levels, different tiers. So we have tier 1 work packages focusing really on this basic material properties, environmental and health issues and related things. And we have also a work package of fundamental science. The second tier is slightly higher in this maturity, focusing on, let's say, kind of component level research, but we have a high frequency electronics work package, optoelectronics work package, spintronics and sensors and so on. And then we have 4 work packages which should have a highest level of maturity, and which are this tier 3 work packages, which are kind of expected to deliver rather easily some technologies out from this project. So these are flexible electronics, energy applications, nanocomposites, and production. Okay, I said that there's they already mentioned that there will be this open call part, but I guess it's expected that this consortium will expand, that there will be an open call part starting in December. And I guess it was already discussed that there's this Horizon 2020 phase expansion as well. Now, these are not my slides, and that's why it was. Yeah. Great. I don't know if I spend enough time, but these key takeaways are really that this graphene flagship is really a 1 billion investment, which aims to build the graphene industry in Europe, really to take this raw potential and make some commercial things to happen. Graphene as a technology and as a material has almost unlimited potential, and this kind of a focused and coherent initiative will exploit that potential fully. And we are really aiming to tackle with several generics challenges in maximizing this impact of publicly funded projects. Yeah, thank you.